All right, no time to waste. So last recording, my audio was kind of muddy. I'm trying to fix that. I think the microphone's on this side. If I wear my headphones the other way, then the microphone is behind me. So here it should be in front, more by my mouth. So hopefully that will fix that. Uh, Last video, uh, we finished most of the reading. So this video, we're gonna finish up the reading and then dive into the exercises. So the last part of the reading is about storage devices. In Linux, storage devices are generally referred as block devices because data is read to and from these devices in blocks of buffered data with different sizes and positions. Every block device is identified by a file in the /dev directory with the name of the file depending on the device type, IDE, SATA, SCSI, etc. As far as etc goes, I'm not sure, honestly. And I'm curious enough to go right to you. I just like using ChatGPT anyway. So let's take this here. We're going to put that in, and then we're going to say, um, list some examples of what the etc could mean, comma, could mean. Yeah. So it should read it back to me. Oh, I got muted. So, they're doing it wrong. Okay, so let me
The
see.
abbreviation etc. can stand for several different things depending on the
Okay,
context.
okay. No, no,
Here are
no,
some common
no, no,
examples.
no, no,
Etc.
no,
This is the
no,
most common
no,
meaning of
no.
etc.
Okay, that was wrong. Let me try it again. And I'm not going to use the voice thing. I'm going to say in the context of the above statement. The above. Tell me uh, what some more device types could tell me some more device types that could be listed instead of etc dot. Okay, so there we go.
Absolutely, there are numerous types of block devices that might have corresponding files in the dev directory in a Linux or Unix-like system. Here are some of them. NVMe, Non-Volatile Memory Express. NVMe is a communication standard protocol developed specifically for SSDs by a consortium of vendors including Intel, Samsung, SanDisk, Dell, and Seagate. USB, Universal Serial Bus. USB storage devices include flash drives, portable hard drives, and portable SSDs. eMMC, Embedded Multimedia Card. These are typically used as the primary storage in smartphones, tablets, GPS units, or e-readers. SD, Secure Digital. These are commonly used in cameras, Raspberry Pis, and other small devices. Virtual disk files. In virtualization environments, disk files such as VMDK, VMware, VDI, VirtualBox, VHD, VHDX, Hyper-V can act as block devices. ISCSI, Internet Small Computer System Interface, a network protocol that allows clients, called initiators, to send SCSI commands, CDBs, to SCSI storage devices, targets, on remote servers. FC, Fiber Channel. A high-speed network technology primarily used for stored networking. Fuse, file system and user space. While not a device type per se, Fuse can provide block-like access to various types of storage, both local and networked. The exact name and convention for these in-dev can depend on the Linux distribution and the specific device and its configuration.
Okay, so I'm really glad I did that because we can see there are, at least 8 different things that could be represented with this etc, and among them are some really key ones. Just I thought in my mind like USB probably fits there, but I got confirmation of that, assuming that the AI is not hallucinating or plotting to take over humanity. eMMC, you'll see that in a lot of smaller devices like Chromebooks and stuff. So that's a common thing to be aware of. But the biggest thing is this virtual disk files, because virtualization is where it's at. So knowing that um, your virtualization, uh, virtualized disk files show up in the dev directory, and there's not like a special place to look at them, I think is important. So before I move on and finish up the reading, I want to do one final thing. I want to pull up my uh, my lab. Okay, and then log into it. All right, and then I want to take a look at uh, the dev folder. So I'm going to do ls, and I'm going to give it absolute path, starting with the root directory. I'm going to take a look at all the files in there. Um, okay, so uh, that looks good. Now I'm going to ask GTP a question. In Linux, how can I enter a ls command so that when I enter the command multiple times, I see the differences between the first time I entered it and the subsequent times I enter it?
In order to see differences in the output of a command run at 2 different times, you can't simply rerun the ls command. You'll need to store the output of the command and then compare
Oh,
it to the output
okay.
of the command run at a later time.
Yeah,
Here's a
okay.
basic way you could set this up in bash shell. Run ls and save its output. This will run the ls command and redirect its output to a file named output1. txt. Make some changes in your directory, like creating or deleting files. Run ls again and save its output. Now you can compare the two outputs using the diff command. The diff command will display lines that are different between output 1, txt, and
Okay.
output 2, txt. The output might require a bit of
All right, so we don't need to hear the rest of that. Um, really simple. So what I want to do is I'm going to actually change directories into this dev. There we go. And then I'm going to make another file, and I'm going to do that by doing ls, and then I want to pipe. I want to redirect the output of the ls into a file called output1, and I want this file to be um, in my home directory. I don't want it to be in this kind of critical dev directory where if anything gets screwed up or deleted, it could cause issues on my system. So I want to put it somewhere else. And then I'm going to name it output1.txt. All right, and now let's take a look at that output1.txt file. So we're going to go cd, we're going to go ls, and there we go, the output1.txt. There we go. Now let's go back to dev. All right, so here's what I want to do, which I think will be interesting. I want to boot up GNS3, and this will boot it up on my remote lab, so I should be able to see all my labs once that's in there. Oh, you know what I'll have to do first? I'll have to start the GNS3 server on my remote lab. Yeah, it's just, and I'll have to update the IP. It got re-IP'd to .12 instead of .8. I do need to go ahead and put a static IP on there, but who's got time for that? It's literally 20 seconds. Well, it's more than that because when you change the IP, you lose access. You know, if you don't have a dedicated out of band, it can be you can lose access to the server, and it can turn into half hour, multiple hours of work when you thought it would just take a few seconds. So here we go. This is all I need to do. Update that there. Apply. Okay. Now, if I go to open and I go to refresh, now it's waiting for .12, but it should still have similar issues because I don't have the application started yet. So I will start it. There we go. So that is now started. Um, I can close the window, um, and I can open a new term. Yeah. So here's all my stuff. So let's just open one. Let's open one for. Uh, let's open my my home lab, the home lab benchmark, and boot this up. This will cause all of my fans to explode on it. I'd be able to hear it from here probably. And then we'll compare the output of the dev file before all of this was up and running to after, and see if those virtual disks show up there. Okay, so we want to see that output in dev. So we're going to do things should be up right now. It just takes a moment for them to boot, but the virtual disks should be live. So let's see what that looks like right now. So I'm going to do ls pipe output2.txt, and I want this to be in my home directory. So I'll give it the relative path to my home directory relative to any directory you're at. This tilde specifies home. So you notice I don't have a beginning forward slash, but I'm using this macro, which includes it. So technically, it's an absolute relative path. It's not important to know if you're using a macro. Okay, so there we go. Output two. Now let's do diff output one.txt output two, and I changed to my home directory to do that diff so that I can use relative paths relative to my present working directory, which is home. That's where these exist. Otherwise, I would have to give it absolute paths. And let's see what. Oh, wow, interesting. Okay, there's no differences. All right. Well, hey, surprises are not necessarily a bad thing. It's a good opportunity to learn from surprises. I have to take a break for a few minutes. I will be right back. All right, I'm back from my break. Everything's booted up now, so let's take a look at. Yep, so we're at the prompt. So maybe I just entered the command too soon. So let's make sure that it wasn't just a timing issue and do it again. So we're going to do ls type the output to this output 2, just overwrite what I had before. All right, there we go. Now go to this, which has these files on it, diff output 1 to output 2. Okay, so that's fair. There is no difference between the two, so whatever information there would have been about the disks, it could be that it's just persistent information. It doesn't vary whether the environment is started up or not. So, yep, I heard the fans going crazy in the other room, so I'm going to shut this down and completely exit out of GNS3 and continue with the reading. Oops, and I'm sorry, I kind of got distracted here. So, yep, and so every block device is identified by a file in the /dev directory with the name of the file depending on the device type and its partitions. And its partitions is important to remember. CD/DVD and floppy devices, for example, will have their names given accordingly in /dev. A CD/DVD drive connected to the second IDE channel will be identified as /dev/HDC/dev/HDA. So those are different disks, and /dev/HDB, another different disk. No partition is specified. Those would be specified with a number. But in these cases, HDA and HDB are reserved for the master and slave devices on the first IDE channel. So CD, DVD drives, because we all know what those are, right? Am I the only one here over 35? Um, those have to start with HDC or later because HDA and HDB are reserved for master and slave devices on the first IDE channel, which aren't going to be they're going to be built in, IDE SCSI storage drives, not removable discs, or not like CD drives or DVDs. So, and an old floppy drive, because we really know what that is. Yeah, uh, will be identified as slash dev slash fd0 slash dev slash fd1 etc. The A drive. Okay, from those could hold a whopping, you know, we're talking double digits in the mega. Yeah, I'm sorry. I'm just going to take a quick minute and talk about the rate of increase in technology. Because, like, when you think about it, I'm an older person and I remember these. I've seen these big. I went to a friend's house and we played video games using one of these big floppy drives. And he was the coolest kid on the block because he had access to these new giant discs. And you know, as the Joneses were completely taking over my family, or sorry, in the expertise, I saw these discs get smaller. I saw more being able to happen with this disc. And now, I'm doing virtual reality. I have my own home lab virtualizing machines. It's just the rate of progress is astounding. But anyway, I'm almost done with the reading. So to finish it up, from Linux kernel version 2.4 onwards, most storage devices are now identified as if they were SCSI devices, regardless of their hardware type. IDE, SSD, and USB block devices will be prefixed by SD. For IDE disks, the SD prefix will be used, but the third letter will be chosen depending on whether the drive is a master or slave. In the first IDE channel, master will be SDA and slave will be SDB. Partitions are listed numerically, paths slash dev slash SDE A1, so 1 meaning the first partition on the disk A, which would be a master disk on the system because it's the A, slash dev SDA2, so the second partition on the master disk of the system. etc are used for the first and second partitions of the device block identified first, and slash dev slash SDB1, comma, slash dev slash SDB2, comma, etc, used to identify the first and second partitions of the block device identified second. The exception to this pattern occurs with memory cards, SD cards, and NVMe devices, SSD connected to the PCI Express bus. For SD cards, the paths slash dev slash NMCBLK0P1, P2, etc are used, and these are for SD cards, used for the first and second partitions of the device identified first, and slash dev slash MMCBLK1, P1, and P2, etc used to identify the first and second partitions. So here it's making it easier because that P there must stand for partition of the device identified second. NVMe devices receive the prefix NVMe as in slash dev slash NVMe0N1P1 and slash dev NVMe0N1P2. All right, so let's finish the reading. It's time for the guided exercises. I'm just going to pause quick and come back to them. All right, I'm back and ready to go. So we finished the reading. So now let's do the guided exercises. And this is a really powerful thing. I've actually done this before, this lesson before, but I wanted to make videos of it. So this technique has been really helpful to me. So here we go. Act as my LPIC -1 tutor. Use the Socratic method. So this is the method of instead of just telling somebody an answer, you ask them a series of leading questions so that they can come to the answer through their own thought process. To teach me the answer to the following question. So the question is, suppose an operating system is unable to boot after adding a second SATA disk to the system, knowing that all parts are not defective. What could be a possible cause for this error? So um, here we go. And I'll turn on the speech for this.
Let's start with understanding the boot process. Can you explain what the computer does when it's trying to boot?
Yeah, so it depends on whether it is a UETF system or whether it's a system that's using the BIOS. So yes, and well, this is a really bad voice to text. So yes, it depends on whether the system is using the BIOS or UETF. If using the BIOS, the system looks for the MBR, master boot record, in the first 440 bytes of the uh, boot drive that is configured first in the boot options menu of the BIOS. If using UETF, the system looks for the EFI files in the SFI partition of the boot disk.
Excellent, you understand the boot process well. Now let's consider our problem. We've added a second SATA disk and the system won't boot. Knowing what you do about the boot process, what's one possible reason the system might not be booting?
Okay, so one possible reason is the second disk. Um, hmm. A second SATA disk and the system won't boot. Okay, but is now here's what I don't understand: is this question? So was it able to boot before? Because I guess is the second disk was not selected as the boot disk, and the first disk was removed. Therefore, the system is trying to boot up using a disk that is no longer present, since the system was never configured to use the second disk.
That's a valid scenario. Good thinking. However, the question assumes that all parts, including the first disk, are still present and not defective.
Oh, really? Okay.
Considering this,
Wow.
let's ponder a different situation. What could happen when we add a new, properly functioning disk to a system that's already working fine? What configurations could potentially be disrupted?
Um, to a system that's working fine, what configurations could? Um, so, I guess RAID.
That's a great point. If RAID array is set up, introducing a new disk might disrupt it. However, in most cases, adding a disk should not cause issues with RAID array unless you're trying to add it to the array without properly configuring it. In this particular case, we're just adding a second SATA disk to the system. Could there be something related to how the BIOS or UEFI system is set up that might cause the system not to boot when a new disk is added?
Not to boot when a new disk is added. Um, Assuming that the first uh, disk is still present and not defective and it was booting up before the second disk was added. Uh, you know what? I'm just gonna say. Well, I'm just gonna think about it a little bit more. Uh, maybe if the second disk isn't formatted properly to use the correct file system. I mean, this is guessing. Guessing is bad. I should just say I don't know.
Yes,
Uh,
file system formatting could be a factor if you were trying to boot from the new disk. However, the question suggests that we're not trying to boot from the second disk. But you're on the right track about thinking how the BIOS or UEFI could be involved. Can you think of any settings within BIOS or UEFI that may influence which disk the system tries to boot from?
I'm just gonna say no. I cannot.
No problem. The BIOS or UEFI of a system controls the boot order, which is the order of devices that your computer will try to boot from. When you added the second SATA disk, the BIOS or UEFI may have automatically adjusted the boot order,
Oh,
placing the new
okay.
disk above the original disk.
That's what I didn't know.
Now, if the new disk does not have a bootable operating system installed, what do you think might happen when the computer tries to boot up?
Okay, so that's what I didn't know, that the boot order in the BIOS or UEFI isn't fixed and might automatically adjust to prioritize a new disk, which isn't uh, set up properly to boot the system.
Yep,
Correct?
some systems may
Yep.
indeed change the boot order when a new disk is added. They might mistakenly attempt to boot from the new, non-bootable disk, causing the system to fail to start up properly. Your understanding is right. Although the second disk is not defective, the problem arises because the system is trying to boot from the wrong disk. It's essential to check the BIOS or UEFI settings when adding new hardware to the system to ensure that the system is still configured to boot in the way you expect. Now that we've worked through this, what steps would you take to resolve this boot issue after adding a new SATA disk?
Okay, so and then the new disk does not have a bootable operating system installed. What do you think might happen when it boots up? So so change the boot order settings. Just write that there.
Exactly right.
Hmm.
You would go into your system's BIOS or UEFI settings and adjust the boot order so that the original disk, which has the operating system installed, is once again the first disk the system tries to boot from. This should resolve the issue and allow the system to boot properly. Remember to save the changes before exiting the BIOS or UEFI settings. Your understanding of the possible boot issue after adding a new SATA disk is now excellent. Great job on working through this problem.
I'm going to ask it the question it asked me. Now, if the new disk does not have a bootable operating system installed, what do you think might happen when the computer tries to boot it up?
When a computer attempts to boot from a disk that doesn't have a bootable operating system installed, it won't find the necessary system files to start up. As a result, it might display an error message indicating no bootable device found, or it could get stuck in a reboot loop, repeatedly trying to boot from the non-bootable disk. So, if the BIOS or UEFI automatically changed the boot order to prioritize the new disk without an operating system, the computer wouldn't be able to boot up properly. It would either display an error message or hang indefinitely, looking for bootable files that don't exist on the new disk. Does that answer your question?
All right, so it does. So let's move on to the next one. I'm going to use that same strategy of the Socratic method. Uh, so paste that in there. Go back up to the original question. Oops, oh, I lost it. Okay, that's okay. Okay, so the question is, suppose you want to make the external video card connected to the PCI bus of your newly acquired desktop computer. Oh, you want to make sure that it's really the one advertised by the manufacturer, but opening the computer case would void the warranty. what command could be used to list the details of the video card as they were detected by the operating system. So this one I know. The first command would be uh, mod. Sorry, it would be ls mod to see all the modules. Or shoot, or would it be? You'd have to figure out which of those were a which of those were your actual video card. And I don't have a video card on my other one. So I think you could do something like ls mod, and then if it was like an NVIDIA card, it would show up here. And then you could do a mod info on it, like that. And then what you're trying to look for um, is is if it's like the version or whatever. So like here's a version number, author license, so like all of that matches, because they could do something like tell you, like for example on my device it says I have a RTX 260 6 GB VRAM, so maybe it's a 250. You could probably see that in using mod info. So my answer to this would be mod info, but let's go through the process of Socratic uh, questioning.
To approach this question using the Socratic method, let's start by exploring your existing knowledge. What do you already know about the LPIC-1 certification and its associated topics? Are you familiar with any commands or utilities that are commonly used to gather system information in Linux? How would you normally check the details of hardware components in Linux system? By understanding your current knowledge and thought process, we can build upon it.
And this is chat 3.5, which Socratic, like really good Socratic questioning, in my opinion, is a little bit AGI-ish. So like I think ChatGPT 4 does it a lot better. Okay, so what command do you think you can use in the terminal to list the hardware devices connected to your computer? So ls mod. Ah,
The lsmod command is a useful command indeed, but it actually shows the status of modules in the Linux kernel, which might not be directly helpful in finding the detailed information of a specific hardware device such as a video card.
oh,
However, there is a command which is specifically designed to report detailed information
yeah,
about the system's hardware.
yeah,
Do
I
you know which
know.
command I'm referring
I
to?
do, I do. So we know this through the question given. It's connected into a PCI bus, so like a PCI slot. um, so it would be LSPCI.
Absolutely correct. LSPCI is the command we're looking for. This command displays information about all PCI buses in the system and all devices connected to them. By default, LSPCI provides a brief description for each device. What might you do if you wanted more detailed information about a specific device, like a video card?
Okay, and then you can plug in. Oh, okay. So if you wanted more information about a specific device, um, you could plug in the address of the card. Uh, and then you could get more. Let's see here. Uh, so I'm just going to say uh, use the switch to plug in the address of the card. I think. Okay. Yep.
That's right, the S switch allows you to specify the device by its bus, device, and function, BDF, address to isolate the information you're looking for. However, if you don't know the exact address of the video card, there's a simple way to get more detailed information about all devices. Do you know what that is?
I think it's mod info.
Modinfo is indeed a helpful command when you need details about a kernel module, but in this case, we're trying to get more detailed information about a specific hardware device, not a module. The LSPCI command itself can provide more verbose output with a certain option. Can you recall what that might be?
Okay, yeah, so obviously I don't quite understand the difference between hardware devices and modules fully to where I get those two confused. So I'm guessing dash B like for both. Yeah, dash B or dash BB to get more information. So LSPCI, there we go.
Exactly. The V or VB options with LSPCI command will indeed give more verbose output. V gives verbose output showing all devices and details about them. VB gives very verbose output showing more details about each device. Using these options with LSPCI can help you to verify the specifics of your video card without opening the computer case and potentially voiding your warranty. So to summarize, what would be your final command to get detailed information about your video card?
Okay, so the most detailed would be this LSPCI dash VB.
Yes, that's correct. Running LSPCI VB in your terminal will provide a detailed description of all the PCI devices, including your video card. However, to make the output more manageable and to focus specifically on your video card, you might want to pipe the output into grep with a term such as VGA, display, or 3D, since these terms are often associated with graphics cards. The final command might look like this. This will show you the detailed information about your video card as detected by your operating system. Very well done.
Okay, yeah, so you can throw a grep in there, narrow it down, make it easier to see. Okay, so then the next, okay, so the question was, suppose you want to make sure the external video card connected to the PCI bus of your newly acquired desktop computer is really the one advertised by the manufacturer, but opening the computer case will void the warranty. What command could be used to list the details of the video card as they were detected by the operating system? And the command would be ls dash v, and then you can do pipe grep for the display card. What is dash e? Dash uppercase e. So extended grep, so it's a regular expression. Okay. And then I is case insensitive. So you can do lspci-v, lspci-v, and you can get the information. Let's take a look at how much more info we get with dash VB. Quite a bit more. So, yep, there's the answer to that. Next question. The following line is part of the output generated by command lspci. There it is. What command should you execute to identify the kernel module? So this is where I was getting confused before. I was confusing uh, information about the hardware module versus information about the kernel module. So let's go to ChatGPT 4 and let's say I was getting confused. Commands used to get information about uh, about hardware devices. I think um, about hardware um, uh, versus commands used to get information about the status of modules in the Linux kernel. Create for me some sort of memory device, such as a monic or whatever else is most effective to help keep me from getting these, from continuing to mix up these concepts in going forward. Okay,
Absolutely, I understand how it can get confusing given the multitude of commands available in Linux. Here's a mnemonic device to help you remember. Let's use hardware as like precise scientific calculations inside to remember LSPCI. This command is used to fetch details about your hardware, especially devices connected via PCI bus. For LSMod, think of it as listing system modules open source. This command opens the door to understanding what modules are currently loaded into your Linux kernel. In summary, hardware is like precise scientific calculations inside equals LSPCI for hardware listing system modules open source equals LSMod for modules. I hope this helps. Always remember to take it step by step when dealing with Linux commands. Practice makes perfect.
okay. So the two mnemonics they gave me for LSPCI, remembering that that's for hardware, is hardware is like precise scientific calculations inside. And then the second mnemonic, which was to remember ls mod, is for modules, and modules are software used by Linux. Listing system modules opens doors. So, not really hitting with me. Let's just move on to the next question. Okay.
Sure, let's take this step by step. The task is to find out which kernel module is in use for a specific device, right? Can you recall which Linux command could provide us with such information?
Okay, so it's the Linux command to tell us which kernel module is used for a specific device. I think this is where we would use lsmod, because now we're talking about software Linux kernel modules instead of the hardware itself. So we don't need a command to list uh, the hardware that's connected to our sockets uh, in our, whether they be PCI ports, USB ports, those sorts of things. We now need a command that shows kernel modules, which would be lsmod.
Good thinking, but not quite.
Ah, shoot. Okay.
LSMod does indeed list all modules currently loaded into the kernel, but it won't provide direct correlation to a specific device.
Oh,
There's
okay.
another command that provides a mapping of devices to kernel modules.
Really?
Can you think of what that command might be?
Uh, I mean, the only one I know is mod info.
The modinfo command is used to show information about a Linux kernel module, which is quite useful. However, it requires the module's name as an argument, which we don't yet know. We need a way to link the PCI device to its kernel module first. So, there's another command that's even better suited for this task. Can you guess what that might be?
Is it lspci?
You're on the right track. The lspci command lists all PCI devices, but it does not directly show the kernel module associated with the device. Although, with certain options, lspci can indeed provide this information. Can you recall what option we need to use with lspci to find out the kernel driver in use?
Dash V?
Close. The V option for lspci provides verbose output, but to see the kernel modules, you'll need a little more verbosity. There's another option to lspci that provides even more information. Can you remember what it is?
So I remember the dash S. Let's see if I can find it in the help. Will dash T do it? Oh, it must be dash K. Although that's the drivers, not the modules. Let's see if dash K is the right answer.
Absolutely correct.
Okay.
The K option to the lspci command shows the kernel driver in use for each device, in addition to the device details. Therefore, to find the kernel module for the device 3 o'clock 0, you would use the command lspci ks 3 o'clock 0. This will give you the information about the specific device along with the kernel module it's using. Well done.
Okay, yeah, I remember they went through that quite a bit in the training. So the answer is dash K. And I'm gonna issue that, oops, LSPCI dash K. Okay, yep, so now we get these addresses. So now we can do LSPCI dash K dash S and plug in a particular address. We go with this one. And now we get information just about that one. We can remove the dash K and just get the general information. Now we can blast it with a full VV to get a lot of information that would normally fill up the whole screen, be hard to read if we didn't weren't able to narrow it down somehow. But we can narrow it down by its address, which shows us where it's actually plugged into the motherboard. You can do all sorts of other things. Let's do one more on it. Let's do um, let's do a dash T. Okay, so now this shows kind of more information about this address. So it's a 6.1. Um, huh. Okay. Well, anyway, we learned more about the options in the LSPCI command. So let's move on to the next question. A system administrator wants so which command should you execute to identify the kernel module for use in this specific device? The answer is lspci K K for kernel module. All right, next question. A system administrator wants to try different parameters for the Bluetooth kernel module without rebooting the system. However, any attempt to unload the module with modprobe-r uh, Bluetooth results in the following error. Modprobe fatal module Bluetooth is in use. What is the possible cause for this error? All right, so this will be the next question. Shoot, that's too bad. Um, hmm, the default model really is not as good when it comes to like the Socratic method, but I'll use it anyway.
What steps have you already taken to troubleshoot this issue?
It was worse. Hmm. Well, that's too bad. What would be really cool is to have two accounts. Um, for this, there would only be an extra $20 a month. Because like this probably took me like 3 hours. I think you get to use, or you get 25 questions per every 3 hours in ChatGPT 4. So like when I run out on one account, I can switch to another account, and I can probably switch back and forth and contiguously use it. That would probably be worth it. Uh, all right. Well, let me just let's see what. Well, here we go. Here we go. I mean, it's in use.
Let's start by understanding the error message. Modprobe. Fail. Module Bluetooth is in use. This error indicates that the Bluetooth kernel module cannot be unloaded because it is currently being used by something in the system. To determine the possible cause, let's explore a few potential scenarios. Bluetooth service or application. The Bluetooth module may be in use if there is a Bluetooth service or application running on the system. Check if there are any active Bluetooth services or applications that might be utilizing the Bluetooth module. Active Bluetooth connections. If there are active Bluetooth connections established on the system, the Bluetooth module will be in use. Verify if there are any active Bluetooth connections with devices such as keyboards, mice, headphones, or other Bluetooth-enabled devices. Dependencies. The Bluetooth module may have dependencies on other modules that are currently in use. Attempting to unload the Bluetooth module without first unloading its dependencies can result in the module Bluetooth is in use error. Check if there are any dependent modules that need to be unloaded first. Now, let's proceed with some questions to narrow down the cost further. Have you checked for any active Bluetooth services or applications running on the system? Are there any Bluetooth devices currently connected to the system? Have you reviewed the dependencies of a Bluetooth module to identify any other modules that need to be unloaded first? Please provide answers to these questions, and we can continue troubleshooting from there.
Okay. Yeah, see how much worse this is? I was really enjoying the other tutor. I wish there I could get information about when this would when the cap lifts. Um, okay, so I mean we had the answers here. Um, the Bluetooth server is still running. There are active Bluetooth connections on the system. There's a dependency. So those are some of the answers. Um, how long has this video been? Okay, this video has been about an hour, so I'm gonna count this as a win, um, and then I'll devote another video to the explorational exercises, the summary, and then the answers. And then that will be the end of this lesson one. So thanks for watching this video. I'm going to come back when my ChatGPT 4 is renewed because that's really, I think, important. Or I think that's a really effective way to go through these exercises, to use that as a personal tutor. So yeah, I'm gonna just wait until that's live again, and then come back this afternoon or evening and and finish up this lesson one. All right, so thanks for watching, and see you in the next one.